Hi guys, hope you are fine. I too am fine. So today guys we are going to attempt this question, and before we attempt it guys, we are going to look to read it and then attempt it. The question reads, obtain the general solution of the differential equation. So this is the differential equation. This differential equation guys is going to be, or it's a homogeneous equation, whereby we say let me just show you here guys. I can put a boundary here like that, so that we say let y be equal to vx, and so therefore guys, dy all over dx will give us v plus x dv dx. So guys, we are going to use this principle. So we note that as we do the question. And so guys, when we now come to do the question, we keep in mind all that. So we shall come and say, now what we have here is that y is equals to vx. So we can actually replace our x with, or we can say that y all over x, this is equals to v, like that. So the first thing guys we do is we divide the whole of this equation with x squared, so that whatever remains we shall replace it with v. So this is going to be x squared here, write dy there, dx equals to here x squared minus y squared plus x y, like that. So let's come and divide here now the whole of it, x squared there, divide here x squared, divide here x squared, and we divide here x squared. So guys, we are going to find, this one will remain dy all over dx. This will be equal to, now this is 1 minus this y over x, that is y squared over x squared, is going to give us v squared, like that, plus now we can cancel 1x there and 1, so we are left with v. So guys, this is the equation now we are going to have. We can now replace dy dx with this, so we shall have v plus x dv over dx. This one now gives us this equation, 1 minus v squared plus v, like that. Now we can solve that equation guys by separating variables, and this is how we do it. We can move this v this side, so that now I can come and write x dv all over dx. This one will now be equal to 1 minus v squared plus v. So if I move this v this side, it will be minus v, like that. So now guys, we shall have 1 minus v squared on one side, and this side we have x dv dx. Now guys, it's time to separate the variables, whereby we have v's on one side and x on one side. So we can now put it like this. Now we have the dv, can bring this 1 minus v here, 1 minus v squared, and this other side we can put dx, that is 1 over x dx, like that. So from there guys, we can come and integrate both sides. Maybe I can start with this 1 over x dx equal to integrate dv all over 1 minus v squared. So for this side, we will have ln x as our integration for 1 over x dx. The other side we can make it to be partial fraction. For this is the difference of two squares. So we shall have something like this. Leaving out first, maybe you can put the integration there first, and then we can put here 1 all over, maybe I can put it like this guys, 1 all over 1 minus v squared. This one can be written as a 1 minus v plus b 1 plus v, like that guys. So now we work out a and b before we integrate. So this one is going to be 1 is equals to a 1 plus v plus b 1 minus v, like that. So that now 1 is going to be equal to a plus av plus b minus bv. Now the coefficient of v this side is supposed to be coefficient of v is equals to 0. So 0 is equals to be a now minus b, and the constant we have 1 is equals to a plus b, like that guys. So we can actually do the simultaneous equation for that. So this one is going to be 0 minus 1 is minus 1, then a minus a is 0, minus b is minus 2b. So therefore b is equals to a half. Then it means that a is also going to be a half, like that. Because if b is a half plus a is equals to 1, then this a is a half. Now guys, I can divide here like this. So that now I'll come and write here come and write lnx. So guys, we shall have on one side 1 minus x dx. This will be equal now to this equation, whereby we shall write our a is a half. Can start with b, and b is a half, so that will be a half there. Then all over, so I can put a 1 all over 1 plus v. We put dv there. Then this one is going to be minus. That will be like that. Not minus, but plus. Like that. So this is a is still a half. A is still going to be a half. 1 over 1 minus v. So now guys, we integrate everything like that. So this side we are going to have lnx, which will now give us a half ln 1 plus v, and this side is going to be now minus ln half. I made a mistake guys, but let me just write it the way it is. I will complete it later. 1 over 1 minus v. So all of it now guys is going to be lnx equals to a half ln 1 plus v. For this one is going to be now, this was plus, this is going now to be minus a half ln 1 minus v, like that. Of course guys, plus a constant. That is a constant. So guys, because the constant we do not know about it, you can still even represent it as ln. You can actually write lnc. It's still okay to represent it like that because we do not know what it means, but what the value of the constant is. Because remember, this is a general equation. So guys, now we shall have lnx now equals to, we can put a half here guys, like that, and then we can now subtract this. In other words, when we subtract, it will be ln 1 plus v all over 1 minus v, like that guys. Plus now our lnc, which we have said it is not compulsory that we write like that, but I'm just trying to modify the equation. It's okay even to write it at c. So we are going to bring this to here, and maybe somebody can ask a question, why would we bring a 2 here when there is no 2 in this lnc? It is because this lnc, or the constant, is unknown. And because the constant is unknown and it can take any value, because we don't have any limits. For example, we don't have a limit from this value to this value. So this constant can be any number. In other words, even if I come and write a half over 2 there, guys, it is still okay. So I can write a half there, knowing that this is just a general formula because we don't know what is a constant. Now I can now put my 2 here. I write 2 like that ln x is equals to, I've transferred my 2 this side. So that now I am left with this and that. So finally this one is going to be ln 1 plus v all over 1 minus v, like that. And now you multiply by c. So that's how, guys, it is going to be. So this multiplying by a half will not change anything, because this is a general formula, and a constant is a constant. For example, guys, you can say even when you come and multiply by that constant, this one will still give us a constant, which we do not know, because this constant depends on many things. So whether we divide c divided by 2, they will still remain a constant. And so, guys, that's why I have divided there. So the constant will not affect anything, guys. So finally, this one we can write it like this. ln x raised to 2 now equals to ln 1 plus v all over 1 minus v, like that, guys. And multiplied by c. So finally, guys, we shall have this as our solution, general solution. It will be x squared equals to 1 plus v all over 1 minus v multiplied by c. And this one will now come to x squared equal to 1 plus, instead of v now we can write y over x, because our v is supposed to be like that, all over 1 minus y over x, like that. We multiply by c. And that's what we get even from our definition, where we were looking for v. You can see that our v, guys, if we begin our question, we have said that our v is equals to y over x. So that's why I've replaced the v with that. And so, guys, we come to the end of our lesson today. Bye bye.